Hello, you're welcome to my math friend, your favorite online math educational channel. In today's lesson, we are looking at mensuration 1 for my high school students. Yes, you need the foundation on this, then you move to mensuration 2. So we shall consider some common two-dimensional shapes. Before we continue, hit the notification button. For more, subscribe if you've not, like, comment, and share. All right, so the first two-dimensional shape we'll be looking at is that of the square. Cool. Now, when you look at the square from the board, the square has all sides being equal, and you have two diagonals which are also what? Equal. Good. And so if we want to find the perimeter of the square, since the lengths are 4, the sides are 4, so we say 4 times what? L. That's the perimeter. So the perimeter is the distance around the shape. Good. Then the area has to do with the space, or the space that this area and the space that the square covers. Good. So that is why you have the cross sections inside. You see that? Very good. So that is the area. So we want to find the area of the square. The area, since all the sides are equal, the area is going to be, just pick one length here and one length here, multiply them. L times L, making L squared. Good. So that is it for square. We'll move to the second shape, rectangle. With a rectangle, all sides are not equal. It's only the opposite sides that are equal and parallel. So this side is parallel to this and also equal. This side is parallel to this and also equal. So they are parallel means that they are moving towards the same direction but never meeting. Very good. So if we want to find the perimeter, that's the total distance around it. The perimeter is going to be, since two lengths are parallel, so you have, and two breadths are parallel, so you have 2 times L plus 2 times B. So it's going to be, if you factorize 2 out, you have 2 times L plus B, 2 times the length plus 2 times the breadth. Good. Then when we want to find the area, that is the space that the shape covers. It's going to be one length multiplied by one breadth, which will cover the entire space. So we have length times breadth. Very well, as you can see. So that is it with the area. That is it with the area. So we have L times B, cut it short. Good. Let's move to the third shape. That is a triangle. The triangle you see over there. Now, we will look at the perimeter, the total distance around the triangle. So the distance will be the sum of all lengths. The perimeter will be the sum of all lengths. So that will be AB plus BC plus AC. That is the perimeter code. But we want to find the area of the same triangle. The area, that is the space it covers, is going to be half times the base times the perpendicular height. Good. So let's know that any side can be the base. A triangle is three-sided figure. So any side can be the base. Good. Now, so let's say this is the base of half times the base and the height. Good. So that is it for triangle. Very well. Now we have types of triangle. We have the equilateral triangle. Sorry, all three sides are equal. We have the isosceles triangle where only two sides are equal. We have the scalene triangle where none of the sides are equal. Then we have the right angle triangle, a triangle that looks like this, where one of the angles is equal to 90 degrees. That's the right angle triangle. So, but the formula is equal for all. For area, it's half times base times the height. Good. I trust that you got it very well. Okay, now let's go to another shape, which is the trapezium. The trapezium. Now, how do you find the trapezium. Now, this is how the trapezium looks like, as you see on the board. Good. You have only two opposite sides being parallel, but they are not equal. So you see that this side is parallel to this side, but it's obvious that they are not equal. They're not the same length. These sides are also different. So that is the trapezium. So let's look at how the trapezium, you see, was transformed, okay, from this state to this state. Now, let's say we cut off the side, the triangle attached to here. When you cut it off, and then you cut it off from the left side, then you add it to the right side. You place it on the right side, like this, on the upper right side of the figure, like this. When you do that, you know your base over here, you have a new base there. So this length is extended, so you have a new base, as you see on the board. So when you want to find the length of the base, the length of this base, the base has become a new base. What you do is that you sum the bases. So A plus B divided by 2. That means that you're having an average of the bases, an average of the bases, as you can see. Good. So it's going to be an average, means that that's why you have half. It's like A plus B over 2. Sum of the bases divided by 2, that's the average. Then times the perpendicular heights. So that will be the area for finding a trapezium or trapezoid. Now, when you go to perimeter, the total distance around it, the perimeter still remains the sum of all lengths. So you have A plus B plus C plus D. That is it with perimeter. Very well. I trust that you really understand this lesson. Okay, we're going to look at other shapes. Other shapes. Very well. Okay, so the next two-dimensional shape is parallelogram. Let's see how the parallelogram was being transformed from its initial state into how it is now. Good. So how do you derive it? Look at this very shape over here. You see, you have the side and you have a small triangle, right angle triangle attached to it. Good. So let's say we cut off this right angle triangle on the left side and we attach it on the right side over here. This is how it's going to look. Now watch this shape carefully. You see, this one looks like a rectangle. Good. Where these sides are parallel and equal, and these sides are also parallel and equal. So since it looks like a rectangle, the area is going to be the base times the perpendicular heights. B times H. Then the perimeter, of course, is going to be the sum of all lengths. So you have side AB plus BC plus CD plus AD. Very good. So that is it with the parallelogram. Let's move to the next one. That is a rhombus. Look at the rhombus carefully. So you see that while the parallelogram takes a section of the rectangle, the rhombus looks like the square. You see where you have all sides being equal, all four sides being equal. Good. These are four-sided figures. So the perimeter, of course, is going to be the sum of all lengths, the sum of all lengths. So we have this. So sum of all lengths. Good. Then the area is going to be, you see that it has two diagonals. The diagonal BD and diagonal BAC, they bisect each other at right angles. Over here, 90, 90, 90. And then they also bisect the angles. Good. So this diagonal AC bisect the angle here. It also bisect the angle here. But diagonal BD also bisect the angle here. So bisect the angle here. You see that the diagonals are also equal. So the area is going to be half times the product of the diagonals. So half times, that is BD times AD, half times diagonal AC times diagonal BD. Very well, as you see over there on the board. Good. So that is it for rhombus. Now with area, area also have the perimeter, the total distance being sum of all lengths, meaning that AB plus BC plus CD plus AD. That will be the perimeter, sum of all lengths. Now when it comes to the area, it also has two diagonals, diagonal AC and diagonal BD. Now they bisect. They are not of the same length. They bisect each other at right angles over here. Good. And then the adjacent sides are equal. So AB is adjacent to AD, which are equal. Then BC is adjacent to CD. So the adjacent sides are equal. That is why you have those marks over there. Good. So the area is also having two diagonals. It's going to be half times the product of the diagonal. So half times diagonal BD times diagonal AC. And it has only one line of symmetry. Line of symmetry is a line that cuts the shape where both sides are the same. So look at diagonal BD. When it cuts the shape into two, this side does not look like this, and it's not the same size. So BD is not a line of symmetry. Look at diagonal AC. When it cuts it like this side looks like this, and it's of the same size. So a kite only has one line of symmetry. Good. So that is it for the kite. Very well.